This assessment asks us to choose whether oxygen or nitrogen will protonate most readily when treated with an acid. It's asking us which atom is more basic. To determine that, we're going to need to look at the resonance contributors for this molecule. We can draw one resonance contributor by breaking the carbon-oxygen bond and depositing electrons locally onto the oxygen atom. That will form a new resonance contributor with a carbon-oxygen single bond, where oxygen has a negative charge, and the carbon has a positive charge. We can draw an additional resonance contributor by taking a lone pair from nitrogen and sharing it between carbon and nitrogen to form a new carbon-nitrogen double bond. That will form a positive charge on nitrogen, while oxygen still has a negative charge. This is the resonance series for this molecule. Looking at these resonance contributors, we can see that oxygen will have a partial negative charge in the resonance hybrid, and nitrogen will have a partial positive charge in the resonance hybrid. That means nitrogen has less electron density and oxygen has more electron density than we might otherwise expect. To be a base, we need to have more electron density, so the oxygen atom with more electron density will be the most electron dense, the most nucleophilic, the most basic, and therefore oxygen will be the atom that is most likely to protonate in this particular molecule.